Okay, we're talking about logs today, and one of the applications of logs that's kind of cool is a Richter scale. I'll explain this more thoroughly once you understand what logs are, but logs are a way to scale things down. Like if you have something on the Richter scale that's a 2.8 on the Richter scale compared to a 3.8 on the Richter scale, that's not just one bigger. It's actually a factor of 10 bigger. Okay, so it's a way of scaling things down to be like closer numbers to each other. So you can get the Richter scale from 1 to 10. There's ever been a 10 on the Richter scale. That would be insane. That would be like the Earth shaking apart. But if you go from a 7.2 to an 8.2 on the Richter scale, that's not just 1 times bigger. That is 10 times bigger. So a 7.2 earthquake isn't that, well, it's pretty bad, but an 8.2 is like, holy crap, that's 10 times bigger earthquake. The ground moves 10 times as much. And so, anyway, it's a way to scale things down to, it's only a 1 to 10 scale, nice and small. But actually, a 1 on the Richter scale compared to a 2 on the Richter scale is 10 times as big. A 2 compared to a 3 is another 10 times as big. See what I'm saying? A 3 compared to a 4 is another 10 times as big. So a 1 on the Richter scale compared to a 10 on the Richter scale isn't just 10 times as big. It's 10 times 10 times 10 times 10 times 10 times as big. Okay, so there's a really wide variety of size of earthquakes, and you can scale it down to a 1 in 10. All right, there's other things like decibels, you know, sound. Obviously, sounds can be from extremely quiet to incredibly loud, and it will, there's a huge range, but yet you can scale it down to decibels, which are a nice, simple 1 to 10 scale. pH is another one. pH is acidity, and that's another one you can do in logs. You can scale it down. All right, so what is a log? Well, you use it for stuff like this. This one will be easy. What is x? X is 2. Okay, but what's x now? 5 to the what equals 22. Ugh. Not so nice, is it? But you can figure out what the decimal is by using logs. All right, so on this one, I will show you the log I would write for this. Okay, log has, this is a whole different language. Log base 5, I'm going to make that a little subscript number. And notice that this base, would you agree that if I was just talking about this right here, that the base would be 5? Okay, so whatever the base is, that base and this number is called the base in the log, are the same. So log base 5 of 22 is equal to x. This is called the base. This is called the argument. And that part there is called the exponent. Now, if you think about it, see, it's right there. It's an exponent. So whenever you are figuring out a log, you are figuring out an exponent. It's hard to get your head around, but when you're doing a log problem, you are finding an exponent. So if I were to write you this one, 8 to what exponent is equal to 64, that's an easy one. Do you have that memorized? 8 to the what? To the 2. Okay, but what if I change it to 60? You don't have that one memorized, do you? But what log would it be? See if you can write it. Did you say log base 8 of 60 equals x? One of the things you'll notice is you got to jump jump around. I'm just going to say jump around. Makes me want to jump around and play the crisscross song. But anyway, go from here to here, and then you got to go back over to there. You can't just read them in the order that they are written. They always jump around, and they go. And when you write them backwards, it's the same thing. They'll always jump back and forth to both sides of the equation. But okay, so log base 8 of 60. You got to put that next equals x, and then you come back here. All right. So then you might be, of course, so that's nice, but what the heck does that mean? That you can actually do on your calculator. There's a button for that. There's a way to get logs done. So grab your graphing calculator. Now, it's not quite as simple as you might think, unless you have the new operating system. Some of you have the new operating system on the graphing calculators, in which case, if you find the log button, it'll give you a way to just go right to this and type in log base 8 of 60 equals what? And I'll tell you that it's 1 point something, and it's fairly big. It's like 1.8 or whatever. How many of you got that new operating system where you can just type it in directly? Only a couple of you. All right, so if you're like most of us, you've got this operating system where you have to say, you have to actually change this. It's called a change of base. You'll learn more about it later, but you have to type in log of 60. I'm just drawing a line right through there and saying log of 60 over log of 8. Log 60 over log 8. And if you type in log of 60 divided by log of 8 equals, it'll give you that number, 1 point something. 1.98? 1.96? 1.97 if you round? Okay. So that means 8 to the 1.97 power gives you 60. Does that make sense? Because 8 squared would be 64, so 8 something a little less than squared would make like a little less than 64, like 60. Okay. How about we check it? Everybody, take your calculator. If you haven't got one yet, come up, borrow one. I have them up here for a reason. Leave me a shoe, leave me a cell phone, leave me your keys, whatever. Don't just sit there, please. And type in 8 to the power of 1.97. 8 caret 1.97. I just want you to see it in action. And I did round that, so that your answer probably isn't exactly 60 then, right? It's really close to 60, but make sense? Okay. So what are we doing? If it was all that simple, it would be, here we go, we'd be done already. But this logs unit is going to last you a few weeks. This is the very beginning, just trying to understand the basics of logs. Now I'm going to do one more. 8 to the I don't know what is equal to 2. Can you make 8 get smaller? You can. Go ahead. Try to write the log for this. Once you got the log written, you'll be able to type it in the calculator. Probably the most important skill is being able to write them back and forth. Like you got to be able to write exponents as logs problems, and then if you're given a log problem, you have to know how to rewrite that as an exponent problem. So this one was log base. What's the base? 8 of, and notice I always got to jump around. 2, and then I got to jump back here. X. So it's log base 8 of 2. You should have typed in log 2 over log 8, unless you have the fancy operating system that does this automatically. And what do you get? 0.3. Isn't that the same as 1/3? Now think about this. 8 to the 1/3 power, the cube root of 8. Does that make sense? Cube root of 8 would be 2. Yay. Okay. All right, so then what if it goes the other way? Log base 5 of 25 equals x. I want you to just ponder that for a moment. No typing it in the calculator. Just ponder it for a moment. If that has to be an exponent, that's really something to the something power equals something. What do you think it should be? What to the what should equal what? What do you think? 5 to the x equals 25. And then, now that you know that, can you tell me what x has to be? 2. So you know that log base 5 of 25 is equal to 2. You see if you can handle this one then. Would you agree that 25 is really 5 squared? And what's x? X is the exponent, isn't it? The answer's 2. All right, I think some brain cells just got burned up there. All right, try another one. Log base 20 of x is equal to 3. Rewrite that as an exponential. All right, sorry. Rewrite that in exponent form. What to the what equals what? Is this coming back? Do you remember it? I taught it in my classes. So it depends. Some of the honors HA classes probably did this pretty hardcore, and so might remember this better. Regular HA classes, I think you did it just for a short time, and so you might or might not remember it. Yes? Yeah, tell me what to write. What to the what equals what?
22.
Do you get how you can do that? You can do that in your head. 20 to the third, that's doable. It's 20 times 20 times 20. Okay, 20 times 20 is 400 times 20. So you could go 4 times 2 is 8, add some zeros, 8,000. So this must have been 8,000. All right, so what does this do for you again? It takes problems that are really, really hard to do otherwise. 5 to the I don't know what is equal to 2.97. I can do that with logs, and you can't do that another way. But once you're starting to write things in log language, there's so many things you can do. It just starts to, you'll see after a while that there's so many problems that you can solve with logs once you get beyond this really simple stuff. All right, so this one would be log, and what's the base? Just look at this, what's the base? 5, so the log base 5 of what? 2.97 equals what? X, all right. And so then you could again say on the calculator log 2.97 over log 5. That's how you put that into the calculator, and you'll be able to get your answer. All right, so we can answer problems that we couldn't answer before. The biggest thing is that you can rewrite these from exponents to logs and logs to exponents. So I'm going to give you a few more of those. Log base 6 of 1 equals x. What does that mean? I'll rewrite it. Something to the something equals something. Make it a base and an exponent and an answer. Don't use the calculator, please. That's not the point. I know you know how to type it in the calculator now, but the question is, what could this be as an exponent problem? It's really 6 to the x equals 1. And now think about it for a second. 6 to the what power would equal 1? 0. You know the answer is 0 without even typing it in the calculator. If you typed in that, log 1 over log 6 has to equal 0. Isn't that kind of weird if you divide something and you get 0? You take log 1 divided by log 6 and it has to equal 0. What does that mean about log 1? If you type in log 1 over log 6 to get this answer, and you know the answer has to come out to 0, then log 1 over log 6 has to equal 0. Which one of them has to be 0 then? Log 1 or log 6? Log 1. All right. Now, there's a lot of different bases that you could have. You know, you could have any number of bases. The most common base is 10. So if you say log 5, you actually haven't told me the base, but I know what it is without you even telling me. The most common base is 10. It's sort of like square root. You now know that you can have cube roots, right? Cube root of 8 is 2. And you know on square roots, the teacher used to always just write it like this when you first learned it? Square root of 16. I bet you didn't even know there was a little squared right there, actually, a little 2 right there for square root. Because the teacher never wrote it. Why? Because the most common root is the square root. And so if you say square root without any little number there, it means 2, because that's the one you use the most. It's the common one, right? This is called common log. Why is that common log? Because it's the most common one. It's got the most common base, which is base what? Base 10. So if you're doing log 5, you're really doing log base 10 of 5. When you're putting it in the calculator and you hit log 5, do you get you're really doing base 10? So the calculator is pre-programmed to do base 10 unless you change the base to something else. All right, so again, if you just type in log 9, you really assumed a base. What base did you assume? Base 10. All right, is there any other base that's important? Yep, there's other bases you can have. In fact, your base can be any number you want, except it's got some rules to it. You can't have a base 0. Not allowed. And you also can't have negatives. So it pretty much has to be some positive number. Can it be a decimal? Yeah. It just can't be 0 and it can't be negative. All right, so it has to be bigger than 0 down there. So if you ever saw this problem, what's your answer? No solution. And let's think about why. Watch for a moment. Do you get that that's negative 3 to the x has to equal positive 9? How could you take a negative number, put it to a power, and have it equal positive 9? Oh, you can't. You might think you can. I know you're thinking negative 3 squared, but remember how this has to have parentheses in it? Okay, I'm going to remind you that. Negative 2 squared. What's the answer? That's negative 4. Some people still haven't caught this one. Okay, as opposed to this. What's the answer to that one? That one's 4. The one on the top is what? Negative 4. You know, that bothers some of you. It bothered me first. Okay. So this negative, it's sort of like it's not really attached. It's sort of like it's multiplied by negative 1 here. And this power has to come first, and then you can get the negative attached to it. Okay. You get the difference there? So what's the answer to this? Be careful. Negative 64. All right. Now, let's talk about a few more of these common situations that you have to get good at. Log base 4 of 4. I want you to just think for a second. If I don't know what it is, I can say equals x. If you were to put that in the calculator, what would you be typing? Log 4 over log 4. Well, if you think about that, aren't they exactly the same as each other? What's the answer got to be? 1. Do you get how then log base 17.8 is, oh, that's a weird 8. Of 17.8 has got to be what? 1. So these are some rules about logs. You start realizing that why would I have to type that in? Log 17.8 over log 17.8. Obviously, the same thing, and so they divide, they're going to be 1. So if these are ever the same, the answer is 1. How about this? Log base 0 of 15. What's that equal to? It's undefined or impossible because why? Think about it. 0 to the what? To the x has to equal 15. Tell me how you can make that happen. Take 0, put it to the what power makes 15? You can't do it. As soon as, if you ever are forgetting that these are like impossible ones, just set it up and say, okay, well, I'll rewrite it. I'll rewrite it as an exponent problem. And then, wait a minute, 0 to the what equals 15? You can't do that. So it is no solution. Okay. Other few situations you're going to come to. Log base 3 of 27. What do you notice about the 3 and the 27? Yes, sir. It is. You are exactly right. 27 is the same as 3 to the 3rd power. What do you think the answer is? 3. It's the exponent. Let me give you another few examples. You'll start catching on. Log base 2 of 4. What's the answer? 2. Because if I rewrite this 4 as 2 squared, the answer is whatever the exponent is on this number. Do you want me to prove that to you? I can prove that to you. Watch. Rewrite that for me. What to the what equals what? What will it be? 2 to the x has to equal 4. Do you get how x has to equal 2? How about this? What if I rewrite the 4 as 2 squared? If I now rewrite it, I got to say 2 to the jump around x to the jump back to the other side equals 2 squared. Do you get how they have the same basis? And therefore, x must equal 2. So, see if you're smart enough to handle this then. No, not that. I'm not that smart either. What's the answer? Because this 144 could really be written as what? No, 144 could be written as what? 12 squared, and therefore the answer is 2. Yes. Okay. All right. That's one of the big patterns. Here's another pattern that you start noticing after a while. Somebody in here is falling asleep. Wake up so I don't have to personally embarrass you. 7 to the, let me think. That kind of threw me off. Okay, if I go with log base 7 of, oh, that's too easy. How about this one? 7 to the power of log base 7 of 10. Whew. That'll mess with your head. 7 to the power of log base 7 of 10. The answer is not 7. The answer is not log. All right, how can we prove it? Is there an x in this thing right now? There's no x in here, is there? So I'm going to say equals x. Do you get that what I have here is actually an exponential? It's something to a power equals something else. So then I can rewrite this as a log. Log, and what's the base in this problem right here? 7, log base 7, and then you got to jump around. Log base 7 of x has to equal, bring it back to here, log base 7 of 10. Now look at it closely. Log base 7 of x equals log base 7 of 10. What's x got to be? 10. All right. So 9 log base 9 of 11. What's the answer? 11. M log base m of 14. What's the answer? 14. All right. Could you do it the long way? Yes. You could say equals x, and then you could rewrite it. Log base m of x equals log base m of 14. And then you could go, oh, the logs are the same. Therefore, the arguments have to be the same. X must equal 14. You see all the different things you can do with these logs? It gets kind of crazy. There's all kinds of different rules in log world. Reminds me of Water World. Have you seen that movie? Kind of a cool idea. What if the entire Earth was covered with water? And there was just a little bit of land. And it was almost like a dream, like there was some mountain somewhere that it was high enough above water to be like there was, so almost the whole Earth was water, and most people were living on that water part, and then they thought maybe they could get to the land. All right, well, you're not in water world, but you're in log land. And in log land, there's all kinds of weird facts, things that are true. Log base 5 times x. And by the way, what base does this have? I didn't write one. What does that default to? 10. Okay. Did you know that in log land, multiply log of 5 plus log of x? Multiplies can be written as adds. It's a land where Kevin Costner grows gills. So, all right. In the movie. Anyway. You need to know a few other things about exponents too. Do you remember this? If you say you've got x to the cube root, that's really the same as x to the 1/3. Do you remember that? You need to remember those. Okay, that's called, the roots are on the bottom, just like in plants. Okay, so what if I square this thing? Where would that go? Is that a root? No, that's squaring. So where should it go? It'll be to the 2/3 then. Why do you care? Because what if they do this? Log who's got the answer? Say it when you know it. 1/2 is right. How could the answer be a half? Because you rewrite this as x to the 1/2, and then it'll be log base x of x to the 1/2, and if these two are the same, that's the answer. So the answer is a half. You get that? Stay focused, please. Log base x of cube root of x to the 5th. You rewrite that as log base x of x to the what power? 5/3 or 3/5. You got a 50-50 chance. But how do you make it better than a 50-50 chance? The what goes where? The roots go on the bottom, just like in plants. The root goes on the bottom. So 5/3 is the answer. Okay. What if I said 16 to the x equals 4? 16 to the... Okay. You say it's 16 to the 1/2? How many of you agree? Raise your hand if you think so. Some of you are afraid that it's a trick question, but you people raising their hand, you're right. Way to be bold. Okay. Now, could I rewrite this with a log? Log base what? Of what is equal to what? Now, just think about this for a second. Now, this one's a little weird. People are used to rewriting this as like 2 squared or something, but we need to write it as 16 to the something. Do you get what I'm saying? We need to rewrite this as 16 to the something. 16 to the what? 16 to the 1/2. Then it'll be log base 16 of 16 to the 1/2 equals x, and now these two are the same, therefore that's the answer. One more on that pattern that you may or may not remember by now. Log 5. Now this is kind of tricky. It doesn't have any base up there, but does it? What does that really mean? And therefore, what's the answer? 5. The answer is 5. Because there is really a base here of 10. All right. Now, let me make sure there is some e's on here. So, you remember what e is? 2.718. Very nice. He's on fire. All right. If you haven't already memorized that one, you might want to write it down. E is 2.718. So if I say I can have any base in the world except for negatives and zeros, so then I could say log could be base e then, couldn't it? It's just a number. Okay? Could be log base pi, any number that's positive. Okay? So then what do you think the answer to this one is? -1. What do you think the answer to this one is? Do you agree that we need to rewrite this as e to the something? That could be e to the what? E to the -1. And therefore, the answer is -1. Okay. All right, let's do a few together on the worksheet, which is forthcoming. Pausing for a moment, hand those out. I know that right now this may seem just like a whole bunch of little silly rules and stuff, but you remember how I've mentioned that this is how they make the Richter scale work. This is how they make decibels work. This is how they make the pH system work, like to pH of like acidity, like how acidic water is. 7.0 is like exactly in the middle, and if it's less or than that or more than that, it's acidic or basic. Anyway, there's a lot more that's going to come on this, but for right now, you're just learning the really basics, so you may not be able to see why these dumb little rules mean anything. Okay, here we go. The top row across there, solve, it says. So A says 4 to the x is equal to 4. Now, do you have to do this in any fancy way? No, you can just look at it and say, what's x got to be? X has to be 1. Good. Now, could you have rewritten it with a log? Yeah, but that's the slow way. If you can just see the answer, go ahead and write it down. Okay, B. 6 to the x equals 1. Think about it. 6 to the what equals 1? What's x got to be? 0. Anything to the 0 power equals 1. Okay. That was B. Part C says 2 to the x equals 32. 2 to the what? X has to be 5. Now, you could do that in two different ways. You could say this 32 could be written as 2 to the 5th, couldn't it? And then this has to equal that. Remember those? If you make the bases the same, the exponents have to be the same. All right. All right, let's... D, you're going to have to change 1 over 125. That's kind of a challenging one. Would you agree that that's the same as 5 to the x is equal to, equals down here, 5 to a power. 5 to the power of negative makes it flip. Negative what? Negative 3 is right. So if this has to be negative 3, then the bases are the same, therefore this has to equal that. All right, let's move on. Let's do a tricky one, number 6. Everybody look at number 6. It says log base 6. Right away, I know what they want me to rewrite the other one as. They want me to write it as 6 to the something. You know what I mean? Because that way those two will be the same. But they don't tell me a 6 to the something. They say log base 6 of 1 over the 5th root of 36. Holy cow. So you just have to be smart enough to know they're telling you to take that and write it as 6 to the power of something. So that your answer will be log base 6 of 6 to the something. If you can figure out the question mark, you've got the answer. So 6 to the what would make it 1 over, well, right away I know the answer has to be negative. This answer has to be negative something. And if it's a fraction, you got a 50-50 chance unless you're smart enough to remember that the whats are where? The roots are on the bottom. Who you're on today? All right. Wait. The roots are on the bottom. Which root is it? The root. That's a 5 down there. And is it being put to any power? No. So I just put a 1 there. Now, just wait. So if I take this and do it, will it really equal 1 over root 36? No. So there's something wrong. Is it not the 5th root? No, it's the 5th root. Go ahead, Mr. V. I know you know what the answer is. It's a 2 there. Why? Because now if I go 6 squared, it'll equal 36. And the negative makes it flip, and the 5 makes it be the right root. Think of it this way. Would you agree that this 36 would be the exact same thing as if I had a 6 squared right there? Now do you see why it's got a root of 5 and a 2 on top? The 2 right there goes right there. The root goes on the bottom, just like in plants. Okay? And then the reason it's 1 over is there's a negative right here. So now that I've got it rewritten that way, that is the answer. So a lot of your assignment today, once you understand what you're doing with the logs, if you're just trying to make these two be the same, and the answer is whatever that is, a lot of your assignment for today is about being able to rewrite things as fraction exponents, like we just did right there. That's one of the hardest kind. All right, let's look at number 8. Number 8 freaks some people out because there's no base. Do you remember what to do? Yeah, if there's no base written, then it is really base what? 10, and that's a hint that you're supposed to take that and write it as 10 to the something. And as soon as you have written that as 10 to the something, like 10 to the 5th, it's not that, but let's say it was, then the answer would be 5. Is it 10 to the 4 or is it 10 to the 3? That's the question. Is 10 to the 4 right? Well, it would be the same as having 1 times 10 to the 4 right. 1 times doesn't do anything, right? So 1 times 10 to the 4, that's scientific notation. Remember that? 1 times 10 to the 4 would be a 1 with 4 zeros. Is that the same as that? Bingo. All right. All right. Log base e of e to the 3rd would be 3. That one's a simple one because they're just the same. But here's the change up for you. There's a shortcut to writing log base e. It's ln. I don't know if you ever noticed this, but your button on the calculator, you've got a log button, you've also got an ln button. What that means is the calculator is capable of doing log base 10, which is what log is, and it's also capable of doing log base e, because ln is the shortcut for saying log base e. So if it's ln of e to the negative 4, do you get that ln is a shortcut for log base e? I'm going to rewrite every time. Honestly, every time I saw ln, I would rewrite it as log base e. Because now do you see what the answer is? Isn't it super simple if I just change that to a log base e? Now it's just jumping right out at you. Boom, that must be it. So I'm encouraging you to, every time you see ln, rewrite it as log base e. Okay. That's a lot of stuff to know.
Interruption for the following announcement. The softball game.
All right. I will help you with 23. Read me 23. Read it to me. Read it to me.
E to the ln 6.
All right. What did I say to do every time you came across an ln? All right. So do that. I'm forging right now. Log base e. Do you remember that pattern? If these two are the same, there it is. Telling you. Trust me on this. Whenever you see ln, write it as log base e. Because that pattern is like this. 5 to the log base 5 of 10. The answer would be 10. If these two are the same, then that's the answer. Yes?
For number 16, it just says like log D1.
No, it doesn't. It says ln1. But you change it to log base e of 1. You are correct. Then if this is one you've forgotten, and that's okay, here's your strategy. Always set it equal to x and solve. E to the x equals 1. And how could that ever work? Only if x was equal to 0. This is a rule. If that number is ever 1, then that means your exponent answer, this answer, always has to equal 0. So if you can remember that, whenever this is 1, the answer is 0. It's simpler, but you're going to forget that. And so try to remember, if you've got a problem that doesn't have an x in it, you can say equals x. And then you can rewrite it. And by rewriting, you can solve almost all these problems. All right, and that's all I have for you for today.